Hello, in this video I'm going to be talking about how to find RNS configuration. I'm going to be including practice problems, and then I will provide 2 extra ones so that you can try them on your own and answer in the comments. Our first 2 problems involve finding RNS from bond-line formulas. So let us start with the one on the left. So for this one, we're going to want to prioritize the atoms or the groups based on the atomic number. So pull out a periodic table and compare chlorine, bromine, oxygen, and carbon, right? Because over here we have a CH3. So you will find by looking at the periodic table that bromine has the highest atomic number. Therefore, it is priority number 1, the highest priority. Next, you will see that priority number 2 is chlorine. Then we have number 3 priority as oxygen. And number 4 priority is the remaining one, carbon. Now what you're going to do is ignore the one on the dash. So ignore the group and the number on the dash, and you're going to count what's left. Now you're going to go from 1 to 2 to 4, so from lowest to highest number. And we see that this is going to be a counterclockwise rotation, which tells us that this configuration is S. Now our next step is to see what's on the dash. The trick here is that if an odd number is on the dash, either 1 or 3 is on the dash, then you must change what you got to the other configuration. So because 3 is on the dash, we have to change our configuration from S to R. So it is not S, but it is R. Let us try the example on the right. So on your own, try to find the priorities. Alright, so we have oxygen. We have a CH3 over here, we have the CH2 here, and another carbon here. You will notice that the atom with the highest atomic number is oxygen, so this OH group will be number 1 priority. Number 4 priority will be hydrogen. There is no atom or group with a smaller atomic number than hydrogen on the periodic table. Now, our job is to compare whether to go to the right or the left for priority number 2 and 3. So let's try to find what's going to be priority number 2. So priority number 2, well, let's compare these groups. Going to the left, we see a carbon. Going to the right, we also see a carbon. We can't make a decision there, okay, because these tie. We need to go on. So we need to ask ourselves, what is this carbon attached to on the left? Well, this carbon on the left is attached to 2 hydrogens and a carbon. What is the carbon on the right attached to? Well, the carbon on the right has 3 hydrogens. And by comparing these two, these hydrogens cancel out, right? Because there's a tie, you can't decide between them. And you're left with carbon versus hydrogen. Knowing that carbon has a higher atomic number than hydrogen does, you will place priority number 2 on the left side. And priority number 3 will be on the right side. Now ignore what's on the dash and count from lowest to highest number. So we have 1 to 2 to 3. This looks like a counterclockwise rotation, which is going to be an S configuration. Now, like we did last time, we need to check what's on the dash. So on the dash, we had priority number 4. 4 is an even number, therefore this is going to be an S configuration. We'll keep the configuration that we first found. Let us find the RNS configuration of the chiral centers for a cyclic molecule. We have 2 chiral centers. We have one in yellow here, and we have another one in blue. So let's find the chiral center in blue first. The one in blue, well, we know that priority number 4 is going to be the hydrogen. Priority number 1 is going to be to the left. Going towards the right, we're going to have priority number 2, because then we compare 2 H's and a carbon with 3 H's. Okay, and then finally this is going to be number 3 for this methyl group right here. So if it wasn't clear why I picked going towards the left as priority number 1, well, just look at it. This carbon right here in yellow is attached to a bromine, it's attached to a hydrogen, and it's attached to a carbon. When we compare this to the things that the other carbons are attached to, we see that on the right we have a carbon attached to 2 H's and a carbon, right? And then we see that this carbon is attached to only 3 H's. Therefore, this one wins. Alright, so let us count. Right, so we're going to ignore what's on the dash. And we're going to count from 1 to 2 to 3. And this looks like a clockwise direction, so that configuration is called R. Now, seeing what we have on the dash, that is an even number, therefore our configuration R can remain the same. Okay, so the blue chiral center has an R configuration. Now let's find R and S for the chiral center in yellow. So this one in yellow, well, we see that there's an implied hydrogen right here on a dash. So let's start numbering. Number 1 is going to be bromine, number 4 is going to be hydrogen, and then let's see what's going to be number 2 and number 3. Going towards the right, we have a carbon here attached to a hydrogen, a carbon, and another carbon. Going to this carbon right here, this carbon is attached to an H, another H, and a carbon that's right here. So when we compare these two things, we see that these hydrogens tie, these carbons tie, and finally we are left with a carbon versus a hydrogen. Carbon wins, so number 2 is going to go to the right. And number 3 will be right here. Now let us ignore what's on the dash once more and count from lowest to highest number. So we see we're going to go from 1 to 2 to 3. This is going in a counterclockwise direction, telling us that this configuration is S. Because an even number is on the dash, we can keep S as our configuration. Let us find the RNS configuration for a Newman projection. So let us find the RNS for the front carbon first, the one in blue here. So our trick is going to work the same. We're just going to number I priorities and ignore what's on the back. So hydrogen will be number 4, chlorine will be number 1, and then let's decide 2 and 3. So we have a methyl versus the rest of the molecule. That back carbon is connected to a Br and an oxygen and an H versus this carbon, which is attached to 3 hydrogens. Clearly, the back carbon will be number 2, so we'll just put a little 2 here for the big circle, and number 3 will be this methyl group right here. And let's ignore what's on the back. Number 2 is on the back, so we'll ignore that. Now let's go from lowest to highest number. So we're going to go from 1 to 3 to 4. This is a clockwise rotation, which tells us it's R. Now let's see what's on the back. On the back we have number 2, an even number, therefore our configuration R will remain the same. Now see if you can find the configuration for the back carbon. To find the RNS configuration for the back carbon, we're going to change our rule. We're going to reverse it. Meaning that if the front carbon is priority 2 or 4, then we will reverse our configuration of the back carbon. So let us assign priorities. Number 1 is going to be bromine. Number 2 will be oxygen, or this OH group. Number 4 will be the hydrogen. And number 3 will be the front carbon, so the carbon in blue here. Now let us ignore what is on the front, and we're going to go from lowest to highest number. So this is going to be 1 to 2 to 4, ignoring 3, and this is a clockwise rotation as well, so we're going to have another R configuration. Now because number 3 is on the front, we can keep our configuration as R. However, as I mentioned, if number 2 or number 4 priority was the front carbon for the back carbon, then we would have changed R to S. Let's find the RNS configuration of a Fischer projection. So let's find the configuration for this carbon right here. So this carbon, let's put it in green instead. We're going to do the same thing. We're going to count the priorities. So bromine will be number 1, hydrogen will be number 4, methyl will be number 3, and this carbon right here will be number 2. Now what we're going to do when we count the numbers in the Fischer projection is to ignore the hydrogen. So we're going to again count from lowest to highest. Is a clockwise rotation, meaning that this configuration is R. What we're going to do for Fischer projections is that if the hydrogen is on a horizontal line, as it is in this example, we're going to reverse the configuration from R to S. If the hydrogen was on the vertical line, here or here, then we could have kept the configuration as R. Now try to find the RNS configuration for the other carbon. So I'll label that carbon in blue. So for this carbon, we're going to assign the priorities once more. Number 1 will be this OH group. Number 4 will be the hydrogen. Number 3 will be this methyl. And number 2 will be the rest of this molecule, specifically this carbon down here. Once more, we're going to ignore the hydrogen, and we're going to go from lowest to highest number. So here we have from 1 to 2 to 3. This is a counterclockwise rotation, meaning that this configuration is S. However, as we see while uncovering this number 4, we have hydrogen on the horizontal line, which means we must change our configuration from S to R. In summary, this chiral center in green is going to have an S configuration, and this chiral center in blue will have an R configuration. Now let's check your progress on this topic. For these two molecules, identify the chiral centers and find the RNS configuration for each. Remember, chiral centers are carbons to which 4 different groups are attached. That is it for this video. Thank you so much for watching, and I will see you next time.